right, hello. Set up. Wow, we got viewers on. Hello, everyone. Oh dear. Hey, Zen. Hello. Feels like forever ago. Feels like forever ago. Yes. All right. All right, so then, hey, Richard. Okay, Richard. Then, since your folks are here, mic check, video check, mic check. OBS broke on me. So the camera and the audio I had to reconfigure just moments ago. Okay, sounds good, which is amazing. Yeah, it's not good. I mean, I don't understand why the camera was not working on OBS. That's why I use for streaming. It just broke. It just couldn't work. Even on an update, still couldn't work. Not good. Not good. All right, today's going to be really cut and dry. Hey, Joshy, how are you? Okay, mic check, video check. We are good. It is now. Hello, everyone. Hello, we are finally back. It seemed like forever ago since we were on Twitch. Like it seemed like forever ago. I mean, we've got at least 3 weeks. So we were away for at least 3 weeks, and we're back. Yeah, it's good to be back. Yeah, I get to do the usual thing. Hello, my name is Ming Chow. I'm associate teaching professor at Tufts, and this is Introduction to Security. So today we're gonna talk. Today's topic is really, 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 really bad code and analysis, namely static code analysis. That's the gist of today. After today, we only have 3 more weeks left on Twitch. So we'll be back on next Thursday. Talk about malware and malware analysis, and a lot of you folks are looking forward to that. And then in 2 weeks, we're going to get into forensics. Yeah, how do you recover files such that were deleted or trashed by way of RM? We'll talk a little bit about law enforcement. And then on April the 25th, where do you go from here? Talk about the opportunities that you have now after taking the cybersecurity course, including courses that you can take elsewhere, things that you should build, list goes on. But today, the topic is going to be on really, really, really bad code examples. And what we're going to do now is I'm going to show you not one, not two, I'm going to show you 3 source code examples. I'm going to need the browser later on. I'm going to log into dirty. Actually, I don't want to do that. Actually, I will need to. I am here on Visual Studio Code. I'm going to make a connection. Oh, there we go. Yeah. We already got an account there. Downloading Visual Studio Code server. Not gonna need. Actually, we'll leave this here. But I'm gonna clear the screen, clear the terminal, and I'm gonna go to my workspace. And I have a folder of really bad code. Oh. Okay, so there are 3 source code examples. There's a Java example, there's a Java example, there is a JavaScript example, and there is C. Remember, folks, for those of you who don't know, just a friendly reminder, Java is not the same as JavaScript. Java and JavaScript share the same word in the programming language name because everyone tried to capitalize on coffee back in the 1990s. Okay, so back in the days, I usually ask you, what do you want to start off with? Java, JavaScript, or C? Which one do you want to start off with? But what I will do today is, instead of asking you what you want, we're going to start off with Java, then JavaScript, then of course, as Hawk USAI said, C. We're going to look into the C code. Okay. The reason why we're going to go look at Java code, then a JavaScript code, and then a C code is because there are things that you probably already have known, and then things that you may or may not know. Okay? One of the things about this course is that, I hate this question so much. I mean, it really bothers me is, in the cybersecurity course, what programming language should you focus on? And the answer is that there is none. I mean, it's programming language agnostic. Um, it's programming language agnostic. If you're going to work in security, you're going to work with all types of different languages. I mean, the world is just never just one language. Now, I don't care whether you think you're a hotshot programmer or not, you really, really don't need much in terms of programming abilities. So, let's take a look at the Java code first. Okay, let's take a look at the Java code. Workspace, no. Bad code. Let's take a look at the Java source code first. Now, just to let you all know, you can make an assumption that all 1, 2, 3 examples of source code work, compile. And here's a Java example. Okay, you may have seen this before, but it's still a good friendly reminder. Here it is. This is a Java program that compiles and runs, assuming that you have the right library, such as a MySQL connector. But that's beside the point. But, don't worry about running it. We don't want to run this program. We don't need to, because you should be able to pinpoint the vulnerabilities in the source code. What are they? Go for it. Tell me the vulnerabilities that are in the source code. You can pinpoint the line numbers. Okay, you can do that. I can tell you this much. I can pinpoint at least 5 vulnerabilities on the source code. Tell me what they are. Okay, you have the SQL injection. Yep, SQL injection. Look at when you're mixing. Here's vulnerability number 1. This has become like unforgivable vulnerability number 2 is whenever you're mixing like a computer program and user input, that's always a bad sign. And in this case, line number 13, when you're concatenating a string with user input to build a computer program, in this case a SQL command, that's obviously bad news. And furthermore, there's nowhere that you see where the user input is sanitized or anything. The second vulnerability, and perhaps the more glaring vulnerability, and the unforgivable one, is hard-coded username and password. Okay, hard-coded username and come on. CWE top 25. Let's take a quick review of this. We're actually going to need this. Hey, the 2024 actually. Oh, no 2024 yet. Hard-coded password. Yeah, here it is. Hard-coded passwords is CWE 798. It's number 18 on the list. This is still a thing. Okay, so this is an unforgivable vulnerability. Like, this is not okay. Like, yeah, here it is. I even show you a few examples here. SQL injection is number 3. So you have SQL injection on line number 13, hard-coded username and password on line number 4 and 5. Line number 4, there's actually another vulnerability on line number 4 and 5, which is the username. the username in this case for the database is root. And that's never a good idea because when you're giving root privileges, when you're using root as a username, that you mean root or add super user or admin privileges, you never want to have a username named root. In fact, a lot of modern Unix systems now have completely cut out the ability of logging in as the root username. Like, this is not okay. So that's your third vulnerability here. And the way you fix that vulnerability, line number 4, is of course on the database side, create a different username and password, different user that is not root, and then give it the permission that the account really needs. That is called the principle of least privilege. When you create a brand new user for a system, you always want to give it the least amount of privileges possible, never the most. Okay? Yeah, and that's another matter, invalid auth. Okay, that is it. So we have 3 vulnerabilities here. Can anyone think of another vulnerability? There's actually a couple of them as well. There's one, at least 3. I can think of 1, 2, 3 vulnerabilities. One of them should be here. No, actually didn't. All right, we have improper privilege management. That's a root issue, right? Oh dear. Ooh, there you go. Log in everyone as admin. Okay. Anyone can think of at least a couple more vulnerabilities that you can see here? I can find 3 of them. There should be 3 more vulnerabilities. I'll give you a hint. Maybe printing out the there you go, Wimter. There you go. That was one of the 3 that's missing. Okay, so now you got a 4th vulnerability. Yeah, it's not a maybe. It's really printing out the exception that could give an attacker information that they shouldn't have. Yeah, that bad. Whenever you're doing um, logging or printing out error messages. Okay, when you are putting error messages for users, it should be as vague as possible. You should never ever give them a stack trace of or full analysis of what went terribly wrong. So you have a serious information disclosure problem here, which is when you are printing out errors or when you're showing errors, errors to the user should always be as vague as possible. Whoops, something terribly wrong. That's it. The full stack trace of the error should be logged internally into a system like Logger4j or Logger or something. So that's another problem. Okay. So that's 4 vulnerabilities. What's the 5th one? I'll give you a hint. Line number 10 is connection. Open up the database connection. Username and password. But is there anywhere that closes the connection? You know, I'm sure you've all written a very simple computer program which opens a file, but you also close the file when you are done. So yeah, there's no closing of the database connection. And that actually can cause more damage than good. And actually, I've been a victim of this quite a few times. Back in the ye good old days when I was writing Java web applications, so server side, I had to basically write code like this. Would for each and every database connection, would have to open up each and every database connection per user. But the problem is when I forget to close the database connection that was open, eventually the whole application would crash. And the reason why the application would crash is because there is a queue of finite number of database connections, like on a system level. So if you have 1,000 database connection open and they don't close, you're gonna have a queue stuck with 1,000 database connection, and you can't go over over 1,000, the hard limit. Then what happens is everyone who tried to do anything on the database side will get a good error saying there is a connection problem. The connection queue is too full. So you have a distributed denial of service there. No one else can do anything in a database on the web app now because you've got to close the database connection. So you got to remember when you open a database connection like on line number 10, you have to close it as well. Okay? Yeah, you don't DDoS yourself, but no, it kind of almost becomes a distributed denial of service attack because if, like, for example, you have 100 users, like you have 1,000 users on the web app at one time, which is pretty low, and then another person tried to do something, at 1,001 person that tried to do something on the web application can't, and that happens is everyone now, the app crashes. And I've had this was a common occurrence for me, probably around 2006, 2007-ish time frame. That was so common. Yeah, so when you actually create a database connection, open up a database connection, you got to close it. The 8th vulnerability, I'll give you a hint, line number 1. I mean, another vulnerability is line number 1. What's the problem with line number 1? Line number 1 is, it's not really a vulnerability, but it is extremely bad code. Yeah, it's the asterisk. You're including way too much stuff. You're including everything in the Java.SQL library, which is a lot. So now you have a performance problem. Okay, you have a performance problem. You only should be importing only the libraries and functions that you really need. Yeah, importing all the modules without knowing what is in there. Yeah, and that's never a good thing. So those are the vulnerabilities of this Java program. So again, let's revisit this. So you have a hard-coded username and password, and furthermore, you have a username that is root. You have not one but two vulnerabilities here. You have a hard-coded credential, and you have improper using, like a improper access control, which is root. The way you protect yourself or defend against this problem is, number one, create a different database user for with the least amount of privileges necessary. Like, for example, like a username like Batman and a password like Bruce Wayne. Wink, wink. Now, you may be wondering where in the world, okay, if you're not going to hard code usernames and password, okay, where are you going to put usernames and passwords? Where are you going to store that? The answer is you want to store username and password somewhere on the system level, namely in memory. And the way you do that is, for those of you who don't know, I'm going to bring up Heroku Java environment variables. You never store username and password at the code level. But on every single system, whether you're on Mac OS, Windows, Linux, or whatever, you can do something called configure environment variables. Environment variables are just key value pairs. Here, I am here on my terminal right now, and I can actually, if you can do a print env, now I'll show you all the key value pairs on your system. And here I am. Here's my environment. This is my listing of key value pairs on my Mac OS. And you can do this on any Unix Linux system by just typing in print env. Print env prints out the environment. Print env utility prints out the names and values of the variables in the environment, which one name / value pair per line. If name is specified, only its value is printed. So you may be wondering, okay, but wait, is this any more secure? And the answer is yes. You know, if your web application get hacked, and the source code gets leaked out, well, everything is right there. A lot of people put source code now on GitHub. In order to actually get the username and password, you actually have to break into the system level, which is a little bit harder. Okay, But, Java environment variables. Now, how you actually would use environment variables on Java is, okay, so here it is. So the way you get and set environment variables in your system is, okay, set your variable. In this case, is like string, whatever your variable name is, equal system.getEnv. There you go. That's how you use an environment variable. Changing, yeah. This is a good one. Now this is a lot of Windows stuff here. To set up your Java environment variable from the Oracle. Here it is. Yep, system.get. So if you want to get, so string username equal system.get.env, something like app username or something. String password equals system.get.env app password. So instead of hard coding, in this case, like root and human horn, you would actually, well, hopefully you use a better username than root. You would store the on your system level, and you do that on Mac OS, man set env. Oh. Let's say Mac OS. Just a couple of different ways to do that. Yep, print env, echo. You can do export variable name equals variable value. That's all that there is to it. And this is temporary too. Now, if you want to set it permanently, you have to edit your bash underscore. This is wrong. No, there's a typo here. Bash underscore profile file on Mac OS. Okay, so we have two vulnerabilities here. Connection stuff, same deal. You can use environment variables for the URL of your data for the database connection. In this case, don't use IP addresses and stuff. Vulnerability here, line number 13. We have SQL injection because you're concatenating a string with code. Use prepared statement, and Java definitely had prepared statements. Make sure you close the connection, database connection. So you would have a finally block. So after the catch, you have something like finally close con dot close. Yeah, so those are the major vulnerabilities here. There's quite a few, but the unforgivable ones are the SQL injection and the hard-coded username and password. Okay. Again, notice something. We didn't even need to run the source code at all. Okay. So now we've looked at the Java example. Let's look at the JavaScript. You know what? I'm not even going to run this code either. Tell me where the vulnerability is. That's it. This is a working server-side Java program. Line number 18. Line number 18 lines. That's it. This JavaScript program only has 18 lines. Where's the vulnerability? There you go. You should like after the capture the flag game, you should be able to pinpoint the issue just like that. One word, eval. Eval is evil. Line number 12, that's where the vulnerability is. Okay? Line number 3, you should be able to pick just like that, vulnerability. Line number 12, eval. For those of you who don't know what eval is, in short, eval is a function. It's not just a JavaScript function, it's a function in every single programming language. Eval takes in one argument, a string. And eval will execute that string as code. And eval is in every single programming language. Well, what you're going to see now, what the funniest thing is, any single document of eval will say eval is evil. Here it is. Here is the official documentation. Remote code execution. Executing JavaScript from a string is an enormous security risk. It's far too easy for a bad actor to run arbitrary code when you run eval. Never use direct eval. There it is. Yada, yada, yada. Okay. Python eval. No warning here. Really? No security risk? Okay. How about PHP eval? There it is, caution. The eval language construct is very dangerous. What about Java? Oh, they have something else, script engine. Haha. Ruby eval. And the funny thing is, and now you're starting to see, is eval supposed to be nasty? Yeah. And there it is. Yep, you can actually do a search for eval is evil, and you can see a lot of literature. Eval function is a powerful and easy way to generate dynamic, generally generated code. So what are the caveats? There it is. And there's just a lot of literature on the issues concerning eval. All right. We're not going to run the code. Nope, we're not going to run this one. All you need to do is pinpoint number 12, eval. Okay? So this is a JavaScript example. That was a big one. Okay, this JavaScript example has eval in it. And that should, that's a vulnerability. Okay, let me show you the C example now. Again, we don't need to run this. And you can pinpoint the vulnerabilities. We'll play the same game with this C example. There you go. 21 lines. Okay, 21 lines of code. And I think this example will actually have a very uncomfortable conversation with vulnerability. Again, I don't need to run this. All you need to do is to eyeball the source code, 21 line, tell me where the vulnerability is. What's line number? Hawks USAI. You are correct. But yes. Stir copy. Why? Explain. Explain why. Hawk USAI. Line number 16. Why, Richard? Why is it bad? I think you folks may have broken the record. Okay, let me ask you two questions. And I guess this is a very important question. You can overflow it, but wait a minute. I have a bigger concern. I have a very important question. Yes, Richard. Who taught you that? Or did you just know that from looking and doing the research? Who told you that? Who taught you buffer overflow? Who taught you that stir copy is really, really bad? Now, I want to ask. Furthermore, really is, did anyone teach you this stuff? Gee, you learned well. Nope, seriously, Hawk USAI. Where did you learn it from? You learned well. I am finally happy. Oh, but no, we're out. Okay, aside from this course, aside from this class, Where have you actually learned buffer overflows and really, really vulnerable C functions? I'm very surprised, Hawk USAI, that you actually listened carefully. Well done. Well done. Very well done. But did they ever teach you the stuff in the introduction to security, introduction to computer science, or data structures, or assembly and architecture course, namely CS40? Ooh. Alright. Well, for the most part, I am still sad, and I'm also not surprised because I've taught this course for over a decade, and I just want to let you know nothing has really changed, which is really sad. So buffer overflows is the idea of, well, hold on, what the hell is buffer overflow? Let's go back to the top 25, the CWE top 25 most dangerous software weaknesses again. The issue of buffer overflow, out of bound write. This product writes data past the end or before the beginning of the intended buffer. Number 1, CWE 787. Often used to describe the consequences of writing to memory outside the bounds of a buffer, or to memory that is invalid, or the root cause that is something other than a sequential copy of excess data for a fixed location. There it is. Number 1, CWE 787, out of bound write. There's also an out of bound read as well, too. There it is. That's a simple example of a buffer overflow. You have an array that is of size 3, but you know that indexing starts as 0, 1, but the indexing will be 0, 1, and 2. You can't write to 3. There you go. Alright. So now, you have seen 1 and 3 and 18 today. Notice there's a certain pattern. I showed you not 1, not 2, but 3 source code. 1 in Java, 1 in JavaScript, and 1 in C. We didn't even need to run the source code. We didn't even need to run any binary, run any computer program. We're given a source code, and we can actually just pinpoint the vulnerabilities just like that. And that's the whole gist of what you call analysis. Okay? So I want to talk a little bit more about analysis in a bit. But for those of you who actually like C and C++, I want to introduce to you this document that I absolutely used for years, and that is called The Dirtiest of the Dirty. And this is from CERN. Yes, the legendary CERN. This is an important reference. This is a common vulnerabilities guide for C programmers like you, for a lot of you here. Most vulnerabilities in C are related to buffer overflow and string manipulation. Why is that? Because C let you do a lot of things. Low level, very fast, without much training wheels, and no security built in. That also means no bounds checking. Okay, in most cases, this would result in a segmentation fault, but specifically crafted malicious input values adopted to the architecture and environment could yield arbitrary code execution. You will find below the list of the most common errors and suggested fixes and solutions. So now let's talk about the dirtiest of the dirty C functions. Let's start with, how many people ever used getsp before? Gets. The standard IO gets function does not check for buffer length and will always result in a vulnerability. There you go. Mitigation, prefer using fgets and dynamically allocated memory. And your friend strcpy. Stir copy built-in function does not do length check. Okay, stir copy built-in function does not check buffer length and may very well overwrite memory zone contiguous to the intended destination. In fact, the whole family of functions is similarly vulnerable. Stir copy, stir cat, stir compare. Okay? The best way to mitigate this issue is to use stir lcopy if it is readily available, which is only the case on BSD system. However, it is very simple to define it yourself as shown below. Okay? Another and maybe slightly less convenient way is to use stern copy, which prevents using buffer overflow, but does not guarantee no termination. For other functions in the family, the N variant exists as well, stern CMP and stern cat. sprintf. How many people have ever used sprintf before? Just as the previous function, sprintf does not check the buffer boundaries and is vulnerable to overflow. Prefer using snprintf, which has the double advantage of preventing buffer overflows and returning the minimal size of a buffer needed to fit the whole formatted string. There you go. Printf and friends. Okay, one vulnerability category is concerning string formatting attack. Those can cause information leakage, overwriting a memory. This error can be exploited in any other printf, sprintf, snprintf, i.e., you put like a format string. Okay, U.S. government doesn't like C either. Yes. Okay. Gee, I actually wonder who actually helped with telling them that. Okay, there's also file opening. So I want to have another conversation. I'm going to talk about this only one time because don't get on my nerves. Some people will argue that using stir copy is okay. Okay, some people will actually like to say, all right, why don't we just increase the buffer size, buffer underscore 1 and buffer underscore 2 here instead of 8 to make it like 16. What's wrong with that idea? Like, what's wrong with that idea? And is continuously using stir copy bad? And I argue a strong yes, it is. Well, first of all, if you actually increase the buffer size of buffer underscore 1 and buffer underscore 2 to something much bigger, well, you waste memory, that's number one. But the other thing is you're still going to have the same exact problems. Okay? Yeah, Taka will use longer string, which they always do. But here's the gist of the matter is, like, if you just continue using stir copy, like most professionals out there know that stir copy is bad. So if you continue to use stir copy in this day and age, it means that you didn't know shit. You didn't know, you didn't learn anything, and you just continuously encourage the continuation of using bad programming practices. Like, no, it's not okay to be using like things like stir copy without, to use stir copy these days. I don't care how careful you are, and you know how often people make mistakes programmatically. Almost always. Okay. So now we've taken a look at 3 examples here, and you notice for each and every 3 examples, we didn't even need to run the source code at all. We can just pinpoint the vulnerabilities just like that. With the JavaScript example, there was eval, and there's a C example, there is a stir copy. Okay? In a lot of cases, you can pinpoint an eyeball vulnerability without even running it. And that is actually an important thing to do. And not only security, but also in your computer programming toolkit. Now, I will run the Java and the JavaScript and the C examples a little bit later on. But now to get to my point, now get to my real gist of today, we're going to talk about 2 types of analysis. 2 different types of code analysis. Okay? One is called static analysis, and the other is called dynamic analysis. And you have to know both of these terminology cold. You have to know these 2. Okay? You have to know the difference between static and dynamic analysis. So what's the difference? How many folks here, I'm actually curious, How many of you folks have ever heard of either static or dynamic analysis? I'm very curious. Like, I also have come to the realization that if you're doing computer science and you don't know what static and dynamic analysis is, that is not okay. No, seriously, how many people have ever heard or have used static and dynamic analysis before? Oh my God. Okay, that's sad. Okay, that's pretty sad. I'm pretty sure, I am almost positive that each and every one of you have at least used dynamic analysis. Okay, there's a big difference between, oh damn, that sucks. So what the hell is a CS degree these days? And they don't even, worst of all, forget about whether you do a CS degree or whether you do boot camp, they don't ever teach you this shit. And none of this, and this is important, on a scale of 1 to 10, yeah, it's a 10. Okay? Here's what static analysis is, and you gotta know the difference now. Static analysis really is code scanning. But here is the key point. The real key point of static analysis is no execution of code or program. Absolutely no execution of code or program. Like what we have been doing. What we've been doing for the last half an hour is that we've just been eyeballing the code. We've just been scanning the code. There has been absolutely no execution of the code or the program. However, there are pros and cons of each and every one of these techniques. Static analysis is code scanning, and there's absolutely no execution of the code or the program. So there's you don't compile, no execution, and that also including compilation. Okay? The big pro is 100% code coverage. That's a huge pro. The con. Con 1 and con 2. Prone to lots of false positives. Well, that's what I'm going to show. Well, that's what I'm going to show right now. Like, so Hawk USAI, that's exactly what I'm going to show next. Another big con is can't find configuration. Okay. Con 3, can't find runtime issues. This also known as DUG. Okay. Examples. All right. There are tons and tons of static analysis tools out there. The most famous one, and probably the oldest one in the book, is called Lint. Anyone ever used Lint before? There it is. Here's JSLint. JSLint.com. Allow. No, I don't want to allow anything. Ooh, there's an unexpected eval here. Alright, all you need to do, how you work lint, is the following. Take a JavaScript code like this one, paste it, linter. Holy shit, 30 warnings. Now, you can see why static analysis tool can be a pain in the ass. This is a real thing. Use spaces, not tabs. Use double quote, not single spaces. Yeah, empty block, list goes on. Whole list of things. Okay? So that's one of the most famous. I mean, every programming language has a. Is there a C linter here? Not Clint. C-lint. Real-time linting of SQL lint tool. There we go. When I was programming, there were no static or dynamic analyzers, no profile, no debuggers, no nothing. Alright. How to use lint. Alright. What's this one? Just a safe for work? Yep. Hey. Hey. Can I actually do that? Now I'm gonna log in. Can I do lint? Nope. There's so many linting code now. Here it is. See? Clang, that for my CPP check, CPP lint, old lint, so many different types of lint. Okay. Well, I can also show you here. JavaScript. Flow is a type checker, static type checker for JavaScript. Flow for JS. Okay. Lint is a lint for every single programming language. Also, if you install Xcode or Android Studio, there's a linter for them already built in. Tired of having to run your code to find bugs? Flow if it identifies a problem as you actually code. Stop wasting your time and guessing. Code smarter. Okay. Things started. Here you go. Flow is a static type checker for your does for JavaScript. Yada yada yada. All right, there it is. Yep. Cannot call square with 2 to be a string is incompatible with number. All right. Oh, yes. You know what I'm going to do now? How many of you have taken CS105? Programming languages, the CS105 type checker. Why is a type checker a static analysis tool? Anyone know? Yep. I don't know if you know, but there's a lot of implications, security issues that actually tie in CS105 programming languages course. So here is my story on why a type checker is so important. Have anyone ever worked with the JavaScript library for Google Maps? So for over a decade, I taught web programming and web engineering. And one of the assignments in that course is actually a project that spans weeks, is to build a small version of a ride-hailing service, Uber. So when you actually use the Google Maps API, when you're plotting markers, when you're creating markers and points on a map, latitude and longitude, latitude, longitude. Does anyone know what's the type? I mean, does anyone know what is the range for latitude and longitude? What's the range? The numerical range. And what's the data type of latitude and longitude? What's the data type? For latitude and longitude points, what's the data type? Hello? Anyone? Anyone ever used Google Maps API, latitude and longitude before? Alright, is this stream dead? Anyone? Oh, no, 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 no. Ooh, no, no, not in, no. No, 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 never integer. Never, ever, ever use integers. No, absolutely not. No. Eiffel Tower latitude, longitude. Yeah, what is the Eiffel? Where's the Eiffel Tower? And the Eiffel Tower, here's the coordinates. First number is latitude, longitude. Latitude should be negative 90 to 90, and the longitude should be negative 180 to 180. And always should be a floating point number. Yeah, or a pair. But the pair should be a pair of doubles, a pair of floating point numbers. Never integers, because if it's integer, it's going to be 48 and 2. Okay? So, and that is going to be a totally different location somewhere on Earth. To make a long story short, why is this important? Because Google Maps, the API, if you're going to be plotting markers or points, the latitude and longitude must be floating point numbers, not strings. If you actually use strings for latitude and longitude, and strings are not floating point numbers, the map will crash. There. And that's why, that becomes a serious bug, and also you can also argue it's a security issue as well too. The types matter. Okay, data types matter. You don't want a mismatch. In the case of the Google Maps API, if you use strings instead of floating point numbers for latitude or longitude, the Google Map will crash. It's going to render a blank page. Okay. So yeah, the CS125, CS10105 type checker. They're also, I'll give you another one. This one is written by Facebook as well. Flow is written by Facebook, but so written in Infer. Let me show you Infer. This one's a little bit heavier. Infer is written by Facebook, developed by Facebook to detect bugs in Java and C++ and Objective-C code before it ships. This is Infer is a static analysis tool. You infer some Java or C++. List of potential bugs. Anyone can infer to use intercept critical bugs before they show help prevent crashes or poor performance. Here. Infer checks for no pointer exception, resource leaks, annotation, reachability, missing lock guard, concurrency race conditions, you name it. See the problem? Bam. Okay. There's also quite a lot of commercial static analysis tool. My absolute favorite is Veracode. For years, Veracode donated an account for this course that we can use. But their product is the static analysis, the SAST. Veracode static analysis. You can request a demo. Okay? Find flaws accurately, prioritize flaws fast, and all that. Now, this is a commercial product, but again, we used to have an account with them. It does end-to-end scanning. Veracode is a commercial product, but I can show you what a static analysis report looks like for Veracode. Okay, nope. Bing! So this was actually a Veracode scan of a former student's project, a Facebook follower counter bot. You get an executive summary. This report contains a summary of security flaws, yada, yada, yada. And it breaks down all the flaws by severity. Very high, high, medium, low. How did the former student use VeraCode? All you need to do is upload either A, the binary, or B, a zip file of the source code. Wait a minute. You can upload a binary like an exe file or a jar file, and the answer is yes. Because VeraCode will actually then decompile it into reverse engineer it into the original source as best as possible. There it is. The module names. Yep, here are the flaws by severity and category. You can do here it is, statics. Scan severity score 74 out of 100. That's not great. That's out of 100 grading. Code injection, cross-site scripting, cryptographic issues, directory reversal, server configuration. And it will actually break down all the vulnerabilities, like code injection. Here it is. Associated flaws by CWE ID. Eval. Yep, there was an eval that was used. Improper output neutralization flag, CWE ID 117. Yeah, again, I mean, CWEs is used quite a bit. Cross-site scripting. Okay, CWE 80. And it will actually pinpoint where in the source code the vulnerability was. Cryptographic flaws, list goes on. Okay. VeraCode, GitHub code scanning. In fact, GitHub now has code scanning built in the repositories. There it is. So now you can use static analysis tools on GitHub. It's actually built in. Code scanning is a feature that you can use to analyze code in the GitHub repository to find security vulnerabilities and coding errors. Any problems identified by the analysis are shown in your repository. In your repository only. Yeah, you actually get billed. There's a whole bunch of third-party tools that are support now. Yep, you can even use VeraCode for GitHub. Up here it is, GitHub workflow integration. Here it is. Yep, they have a whole bunch of documents. Okay. Oh, the architecture of how a static analysis tool is built. There you go. That's cool. This one. Announcing third-party scanning tools, static analysis, and developer security training. I remember this one. I'll post this here. It is October 5th, 2020. Last week we launched code scanning for all open source and enterprise developers, and we promised we shared more on our extensibility capabilities in the GitHub ecosystem. Today we are happy to introduce 10 new third-party tools available with GitHub code scanning. Yep. A lot of students in this class, unfortunately, VeraCode no longer, we don't get a subscription from them anymore. I think it's sync.io. Yeah, sync. SNYK. Give this a try. For especially, this was probably the direct answer for some of you folks. Like Hawk USAI _ give this a try. A lot of people do give this a try. Millions of developers build securely using this one. Yep, here it is. Find and fix vulnerabilities in 5 minutes. Scan continuously, fix with a click. Secure your code as is written. integrates easily, yada yada. People have, I've heard from students say this is pretty good, and you should be incorporating static analysis tools in your development tools if you're writing software and stuff. If you also would recommend you, if you go to the readings for the course, um, there are a couple of articles from the ACM. One is how to use static analysis tools at Google, and one, oh, there it is, lessons from building static analysis tools at Google. Eddie was a former student of ours at Tufts, got his PhD. Static analysis at GitHub. Yeah. And it talks about the pros and cons of static analysis. Chris Weishaupel gave, the legendary Chris Weishaupel gave a talk on static analysis tools, binary static analysis in spring 2012. And hard to believe it's over a decade. Here it is, static analysis. Yeah, you already know. This is analysis of software performed without actually executing the program. Full coverage. In theory, having full application knowledge can reveal a wider range of bugs and vulnerabilities than the trial and error of dynamic analysis. Aha. So, now we can talk about static analysis, trial and error. Okay. Runtime. Okay. The con. Won't give you 100%. Actually, here, it won't give you. No way it'll give you 100% code coverage because, hey, there may be some parts of the program that it's just unreachable. Okay? And example. All right, folks. I'm sure you've all heard of dynamic analysis. You've all used dynamic analysis tools before. You may never heard of dynamic analysis before, but you sure as hell have used probably the quintessential example of a dynamic analysis tool. Snyk. I've heard that recently restlessly because it is safer. Wonder if you have any thoughts about this. Mainly, will static analysis become obsolete in the future with AI and new programming languages? And the answer is, I have no, and the answer is no. Okay, I'm going to say static analysis tools will not become obsolete because you have a very big problem. Number one, there's so much software that is written in C, C++, Java, legacy. You think someone's going to rebuild an entire rebuild the entire Linux operating system? Like, that's like millions and millions, if not billions of lines of code in C? No, never happening. No. Static analysis will not become obsolete in the future. No. No. Absolutely not, because of legacy purposes. That's number one. Second of all, is there Rustlint? Yeah. There it is. Lint is used to help improve your source code. The Rust compiler contains a number of lints, and when it compiles your code, it also runs the lints. These lints may produce a warning, an error, or nothing at all, depending on how you configure things. I mean, yeah, lint is considered safer, alright, because it does check for bounds. Like for arrays, for if you're going to be using stuff like memory. Okay? So, programming languages like Java and Rust are safer because, well, there's bound checking. Okay? There is bound checking. But static analysis, no, that's not going away anytime soon. Okay? Yeah, and any AI deploying AI generated code that hasn't been linted, oh yeah, absolutely. Probably have not been linted at all. Yeah, I didn't know that. The Rust Performance Book. Clippy is a collection of lints that catch common mistakes, and it is an excellent tool to run on. Oh, here we go. Yeah. So there's an argument to say that, I mean, I've heard this argument many years ago that Java, people say, quote unquote, use Java over C because Java's safer. Okay, I've heard that before. I've also heard that, people say use Rust because it's safer than C. Like, okay, but you can't rewrite everything in Java or in Rust. Can't. So static analysis not going away. C not going away anytime soon. But should we be using something like Rust over C? Ideally so. Okay, because it's like, at least it is a lot more memory safe than C. But I want to go back to this, for example. What's the quintessential dynamic what is the quintessential dynamic analysis tool? I'm sure you all have used it before. Hint, hint, you use it at, there is execution of code. It actually requires your A dot out. I'll give you a hint. I hope they still use this tool in 11, 15, and 40. There you go. Valgrind. Yeah, you can still write bugs and see. The most famous example is Valgrind. 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 Valgrind is a instrumentation framework for building dynamic analysis tools. There it is. 2 words, black and white. These are the Valgrind tools that can automatically determine many memory management and thread bugs and profile your program in details. Okay, hey DDBand. Valgrind is one of the most famous tools. It's the most famous dynamic analysis tool. Do they still use Valgrind in 11, 15, and 40? Please tell me the answer is yes. Okay, good. So here is a trivia question for you. Do you know who actually built CS40 and incorporated Valgrind in it? Who? Who do you think? Did anyone want to take a guess who actually designed CS40 and put in Valgrind in that course? Anyone want to take a guess? No, no, not Hansen. Hey Mirza, anyone? Who do you think actually built CS40? Hey Contra. Hey Contra, how are you, man? Anyone take a guess? It is Norman Ramsey. Okay. Norman Ramsey designed CS40. But anyone want to take a guess who incorporated Valgrind into CS15 data structures? So yeah, it was Norman who started the who started the trend of incorporating Valgrind in the academic. But who do you think actually incorporated um, Valgrind into CS15? Anyone want to take a guess? It is me. Yep, it is me. I taught I taught 15 from 2011 to 2013. I had a great time. I had a great time. No one died. It was like but it's like a funniest. It's like I tell everyone, yeah, it was like a roller coaster ride, you know, um, and everyone made it alive, which was wonderful. But I had a great time. Seriously, I was much more heavier on the memory stuff and the implementation, not so much on the algorithm stuff. Um, so there were a lot of successes when I taught CS15, but the reason why I wanted to teach CS15 in my career early was I wanted to actually make the jump from 15 to 40 less of an abyss. I mean, for years I heard that students that took 15 were nowhere prepared in 40. And so now I think the gap has closed a little bit or a lot, depending on who you ask. Um, and that was the reason why I taught 15. I mean, oh, we did a dungeon maze. We had students build an associative array key value pair map in C++. Great time. I had a great time. But the reason why I no longer teach 15 is they wanted someone with a more algorithm focus in that course. So yeah, I had a great time. I only got good things to say. I can always tell people, yeah, I did it. It was fun. I had a great time. But it's good to hear that Valgrind is still a part of 15. All right. So now I am logged in to Dirty Work. Here it is. And more vuln.c. And this is what you saw earlier. This was a vulnerable C program that you saw earlier. Directly from the server. Now it's on the command line. But now I'm going to run it. Watch what happens. And this is the issue of buffer overflows. So I'm going to go to my last GCC. So I'm going to go to GCC, take out the stack protector. So basically this is unsafe. Make the output to be vuln and compile vuln.c. So here it is. The binary is vuln. So, segments, I got a seg fault, I got a core dump because there's no user input. Because this program requires user input. Where? Yep, stir copy. Copy the first argument into buffer 2. Okay, so take a visual snapshot of the source code. So once I type in, let's say, a letter A, it should go into buffer 2. Oops. Clear. Here it is. Buffer 2 is at some memory address and contains the string 2. Buffer underscore 1 is at that memory address and contains the string 1. The value at the memory address is 5. Copying 1 byte into buffer underscore 2. Buffer underscore 2 now is at that memory address and contains 1A. Buffer underscore 1 hasn't changed yet. Okay, not so bad, not so bad. Let's do 2 ways. Okay, copying 2 bytes into buffer underscore 2, and buffer underscore 2, that's 2 ways. Okay, not so bad, not so bad, not so bad. All right, let's do 3 A's. All right, copying 3 bytes into buffer underscore 2. Buffer underscore 2 now contains that yada yada yada, contains 3 A's. Okay, not so bad, not so bad, not so bad. All right, let's take things up a notch and let's do 6 A's. Copying 6 bytes into buffer underscore 2. Alright, buffer underscore 2 contains 6 A's, and alright, buffer underscore 1 and value looks pretty good so far. Okay, not so bad, not so bad, not so bad. Let's do 7 A's. Alright, copying 7 bytes. Alright, not so bad, not so bad. 8 A's. Uh-oh. Buffer underscore, copying 8 bytes into buffer underscore 2. Buffer underscore 2 now contains 8 A's. What the hell happened to buffer underscore 1? Let's do 10 A's. Oh, okay. Buffer underscore 2 now contains a whole bunch of A's. Copying 10 bytes into buffer underscore 2. Buffer underscore 2 contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 A's. But buffer underscore 1 also has 2 A's. What the hell? Let's do 12 bytes. Alright, this is not good. And this is the buffer overflow issue. 16A, 18A, uh-oh, uh-oh, uh-oh. copying 25 A's, and this is where things get completely wonky. Buffer underscore 2 has 25 A's. Buffer underscore 1 is totally messed up right now. And value is also completely messed up. Can anyone understand why value is now this big integer and have a whole bunch of 616161s? 0x616161? Alright, let's put the longest string that we can possible. Bang! Bang! Done. Why? What's the significance of the 61? Here it is. We're doing dynamic analysis on that vulnerable C code right now. What's the problem? Now you see buffer overflow in action. Exploitation, good luck with that. Yep. 61 is the ASCII value for lowercase a. Yep. Yep. So that's why if you do of course, this now illustrates the dangers of using dirty as a dirty function like strcpy. Okay? Not good. No bueno. And sadly, most computer science courses that use C and C++ still don't tell people that to teach the kids. They're just functions that you just cannot use. Okay. I've already shown the example of eval while you played the capture the flags game. And that was in this, there's a reason why eval Homer was a part of this year's capture the flag game. So we're running out of time. But I want you to take a look at this right now, so one last time. So today we looked at some bad code examples. We were pretty good. We did a pretty good job in pinpointing the vulnerabilities in the source code without even running the programs. The Java, the JavaScript, and the C program. What you really have to know today is static analysis, dynamic analysis, what they are, their pros and cons. Because why? Do you really need to know static and dynamic analysis? The answer is yes. Especially static analysis. That's the whole point of the lab after the capture the flag game. The lab on the technical risk analysis. There are vulnerabilities that you can find in the source code just by eyeballing at them. You can legally cheat on the whole lab as well if you use a good static analysis tool. Will you see static analysis and dynamic analysis again? Oh yeah. Next week. Because static analysis and dynamic analysis are very important in malware analysis. See ya.